Okay, take a few moments and do these warm-up problems. You should recall these from Algebra 2. Okay, so what are the possible outcomes for tossing a coin? You can have either a heads or a tails. What are the possible outcomes for rolling a fair dice? You can roll a 1, a 2, a 3, a 4, a 5, or a 6. Remember, tree diagrams, we start with branches. We start with our options and then we make our choices for each one. So for tossing 2 coins, we can either get a heads or a tails. Then for the second coin, we can have a heads or a tails. Or second coin here, we can have a heads or a tails. So we could have a heads and heads. We could have heads, tails, tails, heads, or tails, tails. Those would be this is what's called our sample space. Tree diagram for 2 marbles. We have red, yellow, green for the first one, and we have red, yellow, green for the second one. You could draw 2 reds, a red and then a yellow, red and a green, and so on. I'm not going to spend a lot of time going back over our possible outcomes or our tree diagrams because I feel like that's something that you all should know. If you're not sure, go ahead and look it up in your book a little bit more detail. However, there is one that's kind of a newer one for me. Maybe you've seen it before, but I had not. It's called two-dimensional grids. And it says, what is the possible outcomes for tossing 2 coins? Well, we just saw it from the tree diagram, but what they suggest that you do is you draw a line here, and you draw a line here, and you draw a line here, and a line here. And where those lines intersect, we're going to have our dots. Okay? So we could have a heads or a tails for the first coin. We could have a heads or a tails for the second coin. I have 4 possible choices because I have 4 dots here. One choice is a heads and then a heads. One choice is a tails and then a heads. One choice is a heads and then a tails. One choice is a tails and then a tails. Now, for this example, this grid may not be very helpful to you. You may already be able to come up with those on your own. But when you start adding multiple things, it does make it a little bit easier to figure out what those outcomes could be. All right, so we're going to talk about theoretical probability today. Theoretical probability is really something that you've talked about in Algebra 2 probably and other times. Theoretical probability is a probability that something should happen given all things being equal, or all things being equally likely. Okay? For example, in a basket of 3 green, 4 yellow, and 5 blue tickets, what is the probability of getting a green? Well, first of all, we have to know how many green are there. Well, there are 3 green. Out of how many? 3 plus 4 is 7, plus 5 is 12. So we have a 3 out of 12 probability or possibility of pulling a green marble at random a green ticket at random out of a bag. So you have a 1 in 4 chance of getting a green marble. Try these. Okay. What's the probability of getting an orange? Right. There are no orange tickets in this bag, so 0 out of 12. So what's our probability of this happening? 0. What's the probability of getting a green or a yellow? Well, there are 3 green and 4 yellow, so there are a total of 7 that fit that category out of 12. So 7 out of 12 is our option here. What's the possibility of getting a green, a yellow, or a blue? Well, you have 3 green, 4 yellow, and 5 blue, so you have a total of 12 out of 12, which is 1. Remember, probabilities can range between 0 and 1. 0 is it's impossible to happen. 1 is it has to happen. If these are your only 3 choices, you're going to have to draw one of those out of the bag. Okay? Which is what we just said here. The probability of A occurring is often written as P of A. And the probability of A is occurring is between 0 and 1. Because it's always between not possible and definitely happening. All right, so what do you notice? What is the probability of rolling a 6? Go ahead and do these real quick. You can handle that. All right, what is the probability of rolling a 6? Well, you have a 1 in 6 shot of rolling a 6. What is the probability of not rolling a 6? You have a 5 in 6 shot. What is the probability of rolling a 1 or a 2? You have a 2 in 6 shot, or a 1/3. What is the probability of not rolling a 1 or a 2? Well, there are 4 dice, 3, 4, 5, and 6, that are not a 1 or a 2. Oops, that should be a 6 there. You have a 4 in 6 chance, which is 2/3. Talk with your side partner about what you noticed just a minute there. All right, what do you notice? Yes. Probability of A and probability of A prime is also called not A. So the probability of A and the probability of not A is equal to 1 because the sum of all probabilities has to be 1. So it either happens or it doesn't happen. You either roll a 6 or you don't roll a 6. You either roll a 1 or a 2 or you don't roll a 1 or a 2. You're either a boy or a girl. All those different things. You pull a blue ticket or a red ticket, whatever the options are. The probability of you pull a blue ticket or you pull not a blue ticket. Those two probabilities together have to equal 1. And we're going to use this later on. Make sure you know that. All right, so I'm going to ask you to do this. Use a grid to represent rolling a dice and tossing a coin simultaneously. I want you to try that two-dimensional grid. So take a few minutes here, draw it, and then find what the probability of rolling a head is. Find what the probability of rolling what a tail and a 5 is. Probability of rolling a tail or a 5. And not a tail or a 5. All right, let's take a look at our grid here. We can put the coin on this side, and our two options are heads or tails. For a dice, you've got 6 options, 1, 2, 3, 4, 5, or 6. So let's draw on our grids, our lines. If you have graph paper, this works well on graph paper. Okay, here's our grid. We have choices of heads and tails for the coin, and a choice of 1, 2, 3, 4, 5, or 6 for the dice. Actually, singular of dice is die. How many options do we have? We have a total of 12. What is the probability that we roll a head? Or toss a head? Well, we have 6 out of 12, or 1/2 chance. What is the probability that we roll a tail and a 5? Well, there is only one option. Whoops, not that one. There is only one option that is a tail and a 5. So what is the probability that we do that? That's a 1 in 12 chance. Okay. What is the probability that we roll a tail or a 5? Well, that's got a tail in it. That has a tail. That's a tail. That's a tail. That's a tail. And that has a 5. Okay. If we think about our complements that's not a tail or a 5, what should this number have to be without even having to count? Right, 5 out of 12. Not a tail or a 5. This is not a tail or a 5, not a tail or a 5, and so on. And there are 5 of those left. Okay. All right, I know today's lesson was pretty short. I'm going to give you a little bit of time to work on these problems. Go ahead and get started on these today, and I should see you tomorrow.